a file, save as copy and open. Save it as, you know, something that makes sense to you. And then we can go ahead and insert this. So I'll start with the concentric. And then I'm gonna just grab these sides. Okay. Did not like that. Okay. And then we'll just go ahead and align the top faces. Okay, so now when I spin the gear and the shaft are spinning together. Okay? So that's the first one. Second one is just slightly different, but again, spur gear. This one has 10 teeth. And it's got, let's see, face width of 0.25 and then 0.5, 0.5, 0.25. Face width of 0.25. Hub style is both sides. Hub diameter is 0.5.
Can you go back in and reconfigure a component after you place it?
Yep, I'll show you that in just a second. 1/4 inch, keyway none, and it already makes that selection for me. 10 teeth, and we're good. Okay. So I can always click on the component, right click, and edit toolbox component if I've specified something incorrectly, and get back into that configuration mode for that component. Okay? You're welcome. All right, so this one's pretty much a piece of cake. We don't have a keyway to align off of, so we can, and I'm gonna line up these gear faces, but that may not necessarily be how you wanna do that. But I'll need, I can still spin this relative to the shaft, so I can go ahead and edit that concentric mate to lock rotation.
I remember when to do that, you had to make planes together.
Yes, yeah, in the past, there was no lock rotation, so you had to find planes. So you would have been looking at the planes within the spur gears and trying to line those up with different faces on the shaft planes, which for circular components like this wouldn't have been terribly difficult, but it would have been just another step. Okay. All right, so to line these up, how did we line up our gears before? Remember?
With the axes?
The axes of the
Mechanical mate? Oh, the gears.
before that, yeah. So how did we line them up visually? Do you remember?
The teeth within teeth, like eyeballing it?
Yeah, so we were doing a tooth-to-tooth axis. But these teeth are a little bit different. You can see that you don't have that curvature in there with the corresponding axis, and you can see that you don't get full kind of engagement. This is a more realistic tooth structure than the other ones that we saw in last week's assignment. So the only thing you can try a few different things to line these up. What I've decided to do and what I think probably works best is that I go ahead and put in a tangent mate between those surfaces. Okay, so now that's what your contact would look like. And then I go ahead and
Can you not just do it like a gear mate between the axes of both gears?
you can, but this is just to get them lined up before we do that.
Oh, okay.
So now they're lined up how they would be touching when they spin. And now I can go in and put in my mechanical gear mate and Just make sure that you choose the right axes. I just like to use select other here to know that I'm getting the axis of the gear and not the axis of the shaft. Okay? Wow. That I've never seen before. I'm gonna choose that again just to be sure. Axis of the spur gear, let's try that one. Huh, that's interesting. Okay, wasn't popping up like that before. So we've got a 0.5 to a 0.4. We know that that's not true. We've got 20 teeth on here and 10 teeth on here. So what kind of relationship do we want for those numbers? 2 to 1. So all I'm gonna do is, I'm just gonna change this to a 0.25. We'll get our 2 to 1 relationship, and that makes sure that they visually rotate, in the manner that they're supposed to. So, we should be able to, uh-oh, I went to the wrong side. Alright, I made it to the wrong, okay, when you move, no, I think I made it to the wrong side.
It seems like it doesn't show ratio that it was.
Is it the ratio? Yeah.
Which seems.
Something weird is going on there. It did not do that yesterday. Let's delete it and try it again. It's winned out. Okay. So, I'm not gonna line them up right now. I'm just gonna eyeball it and get it close. Yeah. This is the joy of Solidworks. Sometimes you just do it a second time and it works out. Sometimes it's the third time. Software. Alright, let me make sure. You can also go into your drop-down tree here and select things too. Alright, so there it gave me a different ratio. So I'm just gonna change this one to 1, which is what I did yesterday, and see if that works. Okay. Okay. That seems to be working a little bit better. Okay. Alright, so not too bad. Shouldn't take you all that much time to put this together. We're not looking for, make some just general assumptions based on Jennifer's pictures about how to align the shafts to the base and these two gears to one another. You know, they wouldn't necessarily, it would really depend on how they were mounted, whether or not, I would think that you'd probably have these two aligned a little bit differently than that. But just go ahead and align things based off the picture. Okay, any questions? Okay.
So what was the final ratio you typed in to get it to work correctly?
I had 1 to 0.5. Yeah, yesterday they both popped up at 0.5, and then I just changed 1 to 1 and made it 1 to 0.5. Theoretically, anything should work in there, but that 0.4 coming up was a little bit odd. A 1 to 1, that 0.4 was weird. I'm not sure what Solidworks was thinking there. Okay, something to know. There is a component in here named shaft in the soap delivery system. You also have something named shaft. If you have both of them open at the same time, it will replace whatever one with the other. So either rename one of them or don't work on them at the same time. And if you're going to rename something, rename the gear system before you produce your assembly. So I would come in here Cause we haven't talked about it a lot, but Solidworks maintains file paths and relationships. So if you change a name in just regular old Windows and Explorer, it can blow up some of those file paths that Solidworks maintains. So there's something called Solidworks Explorer. So anytime you are having to modify names, file locations, anything for SolidWorks files, okay, you have to use SolidWorks Explorer. And it's basically like Windows Explorer, except I think a little more tedious. But basically you can change file paths and names. But if I pull something out in Windows Explorer, it's gonna get ugly. We've lost lots of information before by moving things in or changing names in Windows Explorer. Okay.
Can you not inside SolidWorks change the file path of a component anymore? 'Cause
You
remember
might be
doing
able to do it within SolidWorks as well, and you can certainly, while you've got things open, you can rename them and it will translate. But if you're doing mass sort of file management, you definitely want to be in SolidWorks Explorer. Okay. All right, so I'm going to close out of this because any last questions before I move to the drawing? Okay. Because I don't want to interfere with the file name issues. Okay, so on the soap delivery system, I actually have the drawing, but you guys are creating the drawing. So I'll open it up to show you a few things, and then we'll go ahead and create it. All right, so what kind of views are we working with here? What standard views? This one is, you have two projected views here, so typically they would be front and top, yeah. So like if I move one of these, this one doesn't move sideways, so the first one that the person who produced this drawing, which was probably Jennifer, the first one she put in was the top view. And then she projected the front view. And you always, for your standard views, whatever they may be, front, back, left side, top, right, bottom,